Hey guys, 7-1 roots and radical expressions. Okay, there's the view of the curtains. That's great. So, sorry about that. I'm trying to keep the MacBook from overheating. It is just about bedtime. Ooh, moved the controls down to the bottom, and so I'm all a mess. Alright, so finding all the real cube roots. The key word here is all, finding all the real roots, which means it could be positive or negative if it's even. So plus or minus for even, and basically what you see is what you get for any of the odd roots. So the cube root of 0.027, so we've got, I need to work on writing on this thing, but I probably should tilt it so that it's not so. Okay, so we've got 0.027. The cube root of 0.027 is going to be 0.3. And that is what you get, because the only way you can get 0.027 from a cube root is going to be 0.3 times 0.3 times 0.3. If you had a negative involved in there, excuse me, the 0.027 would be negative then. Okay, cubic root of negative 125. Well, this is going to be negative 5 because the only way you can get negative 125 by multiplying a number times itself would be negative 5, negative 5, negative 5. And then finally, 1/64, that is the same root, same thing as cubic root of 1 over the cubic root of 64. The cubic root of 1 is 1, cubic root of 64 is 4. Since this was expressed as a fraction, you should have your answer also in fraction form. Okay, so now, there we go. Okay, so taking a look at the fourth roots. Since this is fourth roots, that means we're going to have positive and negative possibilities because we can get a positive outcome from a negative times negative times negative times negative. Okay, so the fourth roots of 625, I'm going to put that 4 right there. This is, hopefully, a lot of you know that that's 25 times 25. And then that is the same as 5 times 5. And this one is 5 times 5. So the fourth root of 625 would be just 5. But more specifically, plus or minus 5, since it is an even root. Looking at the fourth root of negative 0.0016. This one is not possible. There is no number that you can multiply to itself 4 times and end up with a negative, even if the answer or the value is negative. A negative times negative is positive, times negative is negative, but times that fourth negative would be positive. Okay, so now we just have fourth root of 81 over 625. That's really sloppy, sorry about that. Okay, the fourth root, we're going to go ahead and write this as the fourth root of 81 over the fourth root of 625. Fourth root of 81 is 3. The fourth root of 625 is 5. And that would be your answer. All right, now let's go ahead and go on to the second example, finding the roots. Okay, so the only difference between this example and example 1 is the fact that this one is using those mathematic symbols. Excuse me. Whoops. instead of the language. Okay. So find each real number root. Cubic root of negative 1,000 is just going to give us negative 10. And we're done. And again, that is because that is the same as negative 10 times negative 10 times negative 10. We have a group of 3's. We are doing a cubic root, so it would be negative 10. Square root of negative 81. Is there any number times itself that would give you negative 81? Nope. So this one is not possible. Cannot have a square root underneath the radical for an even root and get a real answer. You can get imaginary, but not real. Okay, example 3, simplifying radical expressions. All right, let's go ahead and take a look at these quick check questions. So simplify each radical expression, use absolute value symbols when needed. Okay, so I'm going to rewrite A so that we write this in prime factorization. So 2 times 2 times, we have x squared, so that's 2x's, y to the 4th, so that's 4, and that is the ugliest y this side of Texas. All right, so we pair up anything, I should say we circle up anything that we have a pair of. Yeah, makes much more sense saying it that way. All right, anything that we have a pair of, we are going to pull one of those numbers out. Excuse me. So we're going to bring a 2 out, an x out, a y out, and the other y. So that's going to leave us with 2 times x times y times y. There's nothing left underneath, so now we just simplify this, and it's 2x y squared. Moving along to B, we have negative 27c to the 6th, and we are finding the cubic root of this one. So that is negative 3 times negative 3 times negative 3, and then we have 6 c's, 1, 2, 3, 4, 5, 6. We're looking for that cubic root, so we're going to look for groups of 3. And there we go. So now we bring this out, we bring this out, and we bring this out. So that's negative 3c times c. There's nothing left underneath the radical, so we just have negative 3 times c, which is negative 3c squared. Okay, finally, we have this 4th root, and I'm going to rewrite it just to give some space. So we have 4th root. Let's go ahead and expand it out. 1, 2, 3, 4, 5, 6, 7, 8. And then there's 12 y's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. All right, now let's go ahead and group these up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So there are 2 x's, and there's 1, 2, 3 y's. Oh my goodness, I don't know why I'm always bad with that one. All right, nothing left underneath the radicals, so then we have x squared y cubed, and this would be your answer. Okay, now final example. See, okay. Now, in class, when I first taught this, I only did it looking at the maximum. Excuse me. let's go ahead and do the way that the textbook did in the other example so that there's some continuity. Nothing wrong with the way that we did it in class because we were taking into consideration what all of the possible boxes we would need. Or, let me rephrase that. Take into consideration what is most realistic because you're going to need one box. One is a fits all. Okay, so a cheese manufacturer wants to ship cheese balls that weigh from 10 to 11 ounces in cartons, have 3 layers of 3 cheese balls by 4 cheese balls. So we have 3 layers of 12. The weight of a cheese ball is related to its diameter by the formula W equals D cubed divided by 5, where D is the diameter in inches and W is the weight in ounces. What size cartons should be used? Assume whole inch dimensions. Okay, so up here, this is our weight. It weighs from 10 to 11. So that's going to go in here. So we have 10 on this end, less than or equal to D cubed all over 5, less than or equal to 11. We're trying to get rid of this 5, so we're going to multiply everything through by 5 because we're solving it for D. So we're going to multiply this by 5, this by 5, and this one by 5. These 5's cancel out, and now we have 50 less than or equal to D cubed less than or equal to 55. Now we need to take the cubic root of this D cubed so that it cancels out. I do not know what those numbers are off the top of my head, so let's go ahead and bring the calculator up. And we have, go to math, is number 4, cubic root of 50 is 3.68. Right. So putting this down here, we have 3.68. And I did not further. Cubic root of a cube is just D, less than or equal to, wrong trackpad. Okay. We've got, okay, that one doesn't work. Cubic root was number 4, and then we have 55, hit enter, and we've got 3.8. Okay, now if we assume whole inch dimensions, then we know that we round this one up, because we're going to go ahead and round that up. We don't want to round it down, and this one we would round up. So D is approximately 4. All right, so the diameter is approximately 4. Now, if we have a layer and there's 1, 2, 3, 1, 2, 3, 4, and each of these is approximately 4, 4 times 3 would be 12. 1, 2, 3, 4, 4 times 4, because your diameter is 4, would be 16. And then as the box goes, there are 1, 2, 3 layers. So 4, 8, 12 there as well. So this would be 12. So it is a 12 by 12 by 16. All right, guys, that is it. I hope you've enjoyed 7-1. I know, I said enjoy. But hopefully it makes a little bit more sense now. Have a good day.